Hello, guys. Once again, guys and gals, trig students, making another video. Um, this one's going to be about modeling with sinusoidal functions. You get into some of the word problems as you go on further into the assignments this week. And it's all about knowing what it is they're asking for. Okay, it's all about knowing what it is that they're asking for. They could be asking for where the midline is. They could be asking for what is the maximum, what's the minimum value for this function. They could be asking, what the period is even. You just have to read the questions very carefully. So I'm going to go over one or two of these with you. So here's the first example that we're going to look at. Let me move the camera down just a little there. And here's our first example that we're going to look at. It says Adidas, and I don't know if I'm saying that name right or not, but forgive me if I'm not. But Adidas dog routinely eats Adidas leftovers, which varies seasonally. As a result, his weight fluctuates throughout the year. The dog's weight, W of T, in kilograms as a function of time and days over the course of a year can be modeled by a sinusoidal expression of the form A times cosine of BT plus D. So automatically just kind of looking at that before we even read the next part, you can see it's a cosine function. You can see that it's factoring in A, it's factoring in B, and it's factoring in D. So there's not a phase shift here. There's not a C. All right. At T equals 0, the start of the year, he is at his maximum weight of 9.1 kilograms. 1/4 of the year later, when T equals 91.25, he is at his average weight of 8.2 kilograms. Find W of T, where T should be in radians. So we're writing a function. We just did this in the previous problems. The previous video that I put up today had this kind of question on it. You're just writing a function. So you're having to identify this key information. It gives it to you in a slightly different form than saying, hey, here's this point and here's this point in coordinates, in parentheses, like we normally like it. But you can write these in parentheses just as well. You can write it out in parentheses just as easily. So if we wanted to do that, at T equals 0, so our points are going to be T, comma, W of T. Our coordinates are going to be in this form. Okay, where T is our basically like our X coordinate and W of T is basically like our Y coordinate. So we're writing the points out. We know that his maximum weight is at T equals 0. It starts at the maximum. That's what a cosine function does. Cosine, remember, starts at the maximum or at the minimum if A is negative, but it's going to start at that maximum value. So that lines up with exactly what we've already talked about. So at 0, it's at 9.1 kilograms. That is a maximum point. Okay. Now, sine and cosine waves, they have many, many, many maximums. They're all the same though, all at the same y value. Until we have to really start messing with the function. We have to add some other factor into the function to make them to where they don't all have the same maximum, or where we started to have waves that bounce higher and higher as you go out further and further and further. And there are such things to where you do that, but that's not what we're talking about here today. So all the maximums are the same on a regular cosine curve, regular sine curve like this. Okay, so we have a maximum. We're also told that he reaches his average weight at T equals 91.25, and his average weight is 8.2 kilograms. What is the average weight in terms of the trig function? What's that average going to be? Where a trig function, a sinusoidal trig function, I should say, which is sine and cosine, what is the average value for that function? Where does that fall geometrically along the graph? Hopefully, you're realizing that that should be the middle. Okay, because average signals the middle, as it always has. So if that's the middle, that's the midline. So the midline is going to go, this is a point that intersects, this is where it intersects the midline. Okay, and let me show you my coordinates to what I've written down so far here. So those are the points that I've got so far. 0.91, or no, sorry, 0.0 comma 9.1, I should say, forgive me, and 91.25 comma 8.2. Okay, the first point's the maximum. This point is where it intersects the midline. Okay. Well, first of all, if we know how to figure out the difference in the y right there, your distance from your midline up to your maximum, what is that? That's the amplitude. So if you want to find the amplitude, subtract your y coordinates of those 2 points right there. And if you do that, you do 9.1 minus 8.2. You accidentally do it the other way around. Remember, amplitude is positive unless we start at a minimum. But you always want to do the top minus the what you want to do is you want to go left to right. So, or, well, even if, whichever, think about it, whether it tells you it's a maximum, it's going to be, A is going to be positive. It's starting at a minimum, it's going to be, A is going to be negative for cosine, okay? A negative in front of a sine function, just saying, just side point here, that just, instead of the function, sine curve like it normally goes up, and then comes down and goes, does that motion, except I'm doing it the opposite way I should. It normally goes up, comes down, and drops back down, and then starts right back there where it starts again, and it repeats the pattern again and again and again. Instead of going up first, if a negative is in front of a sine function, it will go down first. That's the only thing that changes. So, but this is a cosine function, so back to this. We subtract 9.1, or take 9.1 minus 8.2. When we do that, we get 0.9. That's our amplitude. Okay, that's how our function starts. So we're going to go ahead and type that in there. 0.9 times the cosine. Now, we already know, we don't know what needs to go in here with the b. We don't know b just yet. We could figure out d really quickly. We've been doing that, and I think we should just be consistent. Finding the vertical shift first would be a good idea. So, and I'm sorry, my chair's a little squeaky. Forgive me. I'm sitting at my kitchen table. So we got to figure out what d is. Okay. Well, that's how much it's been translated. Normal, remember, normal midline, default midlines, y equals 0. This has been moved though, because it's not there. The midline for this function is that y coordinate of that point right there, 8.2. That's the midline. So this thing's been shifted up 8.2. Okay. Now we just got to figure out, excuse me, we got to figure out what goes inside the parentheses. We got to figure out b. So if we want to figure out what b is, that's the period. That's going to have something to do with the period. Okay, we need to figure out, now we're talking x. Okay, everything we've done so far has been y, all about y. Midline, amplitude, they're all about y. Period and phase shifting, which we don't have to take care of in this case, but period and phase shifting have to do with x. Okay, so this has to do with x. We've got to move something side to side. So this cosine function, it starts, or we don't have to move side to side, but we've got to stretch and shrink and whatever. We got to figure out what the period is. We're not phase shifting here, so we're actually not picking the whole graph up and moving it side to side or anything. So this function, it starts at 0, so it's not been phase shifted. But we know that it goes to 91.25. That's when he reaches his average weight. When is he going to reach his maximum weight again? That's the trick to find out. Well, let me just kind of draw, and I haven't done this, and I probably should have. Let me just kind of draw, I'm going to draw a picture here, but pretend like my, Okay. That's not the best picture in the world. Okay. Obviously, this over here is a little bit higher than this over here, and really they should be the same. Let me see if I can kind of somewhat trim that off a little bit. There we go. Okay. I know, not a whole lot better. All right, so this is what a cosine curve looks like. Now I've changed the x-axis. That's not the x-axis. The x-axis is somewhere else on the graph. That's the midline. I label it the midline instead of labeling the x-axis. We know that it starts here at 0, 9.1. And we know that it intersects at this point at 91.25, 8.2. Okay. All right. That distance right there, if we look at that x distance between those 2 points, that's going to end up being a fourth of the distance all the way out here to the next maximum, because if I find the minimum right here, and then I find the next point where he's at his average weight, and then I find the point where the maximum is, those intervals right there in terms of x, even though I didn't draw it very good, okay, I know I'm not an artist, told y'all that many times. That x difference right there should be the same over each one of those intervals. They should all be the same. So at the minimum right here, we should be, in theory, we should be looking at a function that is, we should be able to take that midline. If we take 8.2, and if we subtract 0.9, we get 7.3. I just took the midline and I subtracted the amplitude. The amplitude is the distance between the midline up to the maximum or the midline down to the minimum. So I could figure out what the minimum is. I could figure out where it's at in terms of y at least. Now, that would be at 7.3. But if I figure out the x difference, well, we went 91.25. So if we take 91.25, we go another 91.25. That should be the x coordinate of where this occurs at it, which is 182.5. Okay. That's where that minimum is going to occur at. Y'all forgive me. I'm trying. All right. So this gives me that coordinates right there. So I'd have to go another 91.25 to get to this point right here, and I'd have to go another 91.25 to get there. So I had to go 1, 2, 3, 4 times 91.25. That's going to be the period. So if I do 91.25 times 4, I get 365, which should make sense in terms of the problem, because how many days are in a year anyways? That's kind of funny that ended up like that. So we'll put 365t, which we know we will not. What did I do wrong? What am I starting to do wrong right here? What's the period? Is it b? No, it is 2 pi divided by b. So 2 pi divided by b will be 365. We know the period's 365 because we counted it out. So 2 pi over b has to equal 365, but we don't, to write the function, we need b. So we've got to solve that for b. So we'll multiply both sides by b, just like we did. If you watched my other video, you've seen this already. So you multiply by b, you get 365b, and then you divide by 365. So 2 pi divided by 365 is what is equal to b. Okay. Does everybody follow? Hopefully, I hope. So that gives me the period. No, not the period. That gives me the b value, I should say. It's very easy to get those confused, guys. Look how many times I'm saying the wrong thing. Forgive me. Be very careful with that. So the b value will be 2 pi divided by 365. We'll put our t in there. Don't forget that variable. I'd hate for you to get the whole thing wrong because of that. And then we check our answer. Got the right answer. All right, so let's look at one more question and see what this is like. This has you write another function. So another same thing. We've got an expected daily rainfall. Excuse me. Expected daily rainfall. We want the average value, or which is at the average value throughout 1 year. Expected value, average value. If you take statistics, you'll learn that those words kind of mean the same thing. All right, so 1/4 of the year later, you get the rainfall is at its minimum. So it starts at the average value, goes to the minimum. So this sine function, it goes down first. That's key. That's going to mean that A is negative. And you can figure out what that A value is. The minimum is 1.4 millimeters. So if the average is 2.3 minus 1.4, you get your actual amplitude there of 0.9, but you need to put a negative in front of it because we're dealing with a negative function. Then you want to figure out that the midline is at 2.3, so it's been shifted up 2.3. That gives you your vertical shift. And then you also want to figure out the 2 pi over b, which is going to equal 365, which gives me the same b value that we just had for that last example. That last example. So I get 2 pi divided by 365 t, and I'm going to check my answer, and I have the right answer. So it looks like that's what you're having to do, is just write functions on this. So, but if you were asked questions where you had to actually figure out some sort of application or something to it, where you were having to figure out some sort of key feature, a maximum or whatever, you have to use your given information to try to figure that out. Okay, you could be asked to do that, I guess, at some point. Hopefully this video was helpful. I'm going to upload this in a little bit, and hopefully, but you all will already see this by the time that you see it. It'll already be uploaded, so it's silly of me to say that. Anyways, let me know if you have any questions. As always, just hang in there. We got this. We can do this.